Now come back to the second application of the Gauss law. In the first application we are discussing about the strength of the field due to the point charge. Okay, now come back to the second. Infinity line charge is there. Okay, we are considering that one line. Okay, one line charge is there and the symmetrical distribution about this one. Okay, so this is the line charge. Okay, and whatever the charge over this is equal to the Q is equal to rho L into L, whatever the length of this line. Okay, whatever the length of this wire you have considering, and this is the charge, whatever the charge density, linear charge density, rho L, it means the linear charge density. Okay, so it depends on whatever the these notations you will use. Okay, so now what will happen, so total charge is equal to whatever the length multiplied by the what is the linear charge density over that. Okay, so Q, again what is the Gauss law, Q is equal to closed integral of d dot ds. Okay, again you know that if we have to be consider, okay, so d is coming like this. Okay, in the 360 direction like this. Okay, if you see this one na, in same इस तरह इसके चारों तरफ 360 में घूमता हुआ नजर आएगा, इसके चारों तरफ। तो हर एक पॉइंट से देखोगे ना तो एक इस तरह के सिलेंड्रिकल वो बनते हुए चले जाएंगे। तो यू हैव टू बी कंसीडर ए सिलेंड्रिकल surface around this wire. Okay, so this will give you the better idea. So Gaussian surface may be any surface. Okay, but it should shows that d should be constant. ओके जब आपका d कांस्टेंट होगा तो हम वो सरफेस लेंगे जो हमारे मैथमेटिकल कैलकुलेशंस को इजी करेगा। ठीक है ना, तो उसके बाद जो है डी डॉट डी एस लेंगे, तो डी तो आपका कांस्टेंट है, क्लोज इंटीग्रल ऑफ डी एस। अब आपको पता है सिलेंडर का जो वो होता है कितना होता है, 2 पाई आर एच है ना। हेयर रो ले रहे हैं हम लोग क्योंकि सिलेंडर है, तो वी आर कंसिडरिंग रो फॉर द सिलेंडर, वी विल कंसिडर रो इन द इलेक्ट्रोमैग्नेटिक्स. ओके, and if you will deal with the mathematics, they will usually consider it r. Okay, so 2 pi rho h, rho is simply the distance from the wire. Okay, and h is the height, whatever the height of this surface you are considering into dp. Okay, so this is the total charge enclosed in that. Okay, so I have shown this one. You can see this rho ds. So this 0 to h and this pi is like this one. So this is 0 to 2 pi. If you integrate within the limit, you will get 2 pi rho h. Okay, but you basically why we are considering the symmetrical space, because we all know all those formulas. What is the surface area of this one? What is the volume of this one? So quite easier. Okay, no need to be go in that much depth. Okay, so simply you will get d. From here you will get d is equal to rho L, because Q is equal to rho L into L, and L is nothing but this is the height of the cylinder. I am considering that much. Okay, that much part. So rho L into h divided by 2 pi rho h. H cancel out. You will get rho L upon 2 pi rho. Okay, so this rho is the linear charge density, whatever the charge density over this wire. Okay, and this rho is the distance from the, this is the Gaussian surface, this is the distance from the wire. Okay, so 1 upon rho L by 2 pi rho in the, and the direction of this flux is in the direction of rho. Okay, it is going outward from this direction. Okay, so this is the Gaussian surface. So hope you will got it. Okay, and in the next lecture we will discuss, okay chalo, in the same lecture we will discuss about the infinity charge sheet. Okay, infinity charge sheet. So what actually happening, we are considering one sheet of paper. Okay, like whatever your notebook paper is there na, like this, and it is consist of the symmetrical charge distribution over this. Okay, this sheet of paper, kind of paper is there, and having the symmetrical charge distribution over it. Okay, so this time I will consider some rectangular surface. Okay, I am considering some this rectangle box type surface, and what actually happening, suppose this is your paper, so it is coming out. Okay, है ना, you can imagine in the z direction, take a paper in your hand, notebook in your hand, you just imagine one rectangular sheet coming out of the paper, and this is below the paper. Okay, like this this is there. So this is the surface area na, this one. So whatever the in the dark I have shown, this is the surface area of the paper, and I am imagining this is the imagine surface of this one. So what will happen, Q is simply, this is the Gauss law, Q is equal to closed integral of d dot ds, and ds is the constant, as you know that, because we are considering the symmetrical surface. Again, now we will consider the Gaussian surface is that rectangle, this cube, you can say this is a cuboid. Okay, kind of cuboid is there. So cuboid, it is having 6 faces. So top, bottom, okay, this is the top, okay, this is the direction of the surface, whatever the symmetrical surface is there, and this is the bottom, downward, upward, and the all 6 faces of this one. Okay, so keep in mind that whatever the faces now on that faces, so what will happen, like this, your D is na electric flux is coming out like this. Okay, and the area you are considering this one. So whenever flux and this one, so what you will get 90. So simply cos 90 is going to be 0 over here this way. So that is why this faces 1 2 3 4 faces. In the 4 faces of this cuboid is nothing, no flux should be there in 4 faces. Okay, so top and bottom is there. Suppose I am considering the area of the sheet is A, so simply rho as hai na, because charge is there, charge and surface charge density into area, rho A is equal to ds multiplied by A plus A, because consider this is the area of the sheet, this is the area of sheet. Okay, so rho as this is the surface charge density. Keep in mind that rho L linear charge density on simple in one dimension, surface charge density rho S. Okay, and this is rho V, this is the volume charge density. Okay, so this is rho A, that is equal to ds A plus A, and rho S into A, that is equal to ds 2 into A. So A cancel out, simply ds is equal to rho S by 2. So this is for the sheet, the electric charge density, that is equal to surface charge density divided by 2. So electric field is rho S by 2 by 2 upon epsilon, because D and E are associated as D is equal to epsilon E. Alright, if you see this one, D is equal to epsilon E, so simply you will get rho S upon 2 epsilon. Okay, now, so in this way you understand. In the same lecture I have discussed what is the how to determine the electric field strength in D. Electric field strength in terms of the density or intensity depends on you. If you got the density, definitely you can calculate the intensity, and if you know the intensity, you can calculate the density. So in the linear charge density, what is there? Okay, what is the expression? For the infinity charge sheet, what is the expression of that? Okay, in the next lecture we will discuss about the uniform charge sphere we will consider, and we will see what exactly is happening here. Okay, so thank you, and have a nice day. We will see you in the next lecture.